Hello everyone. My name is Daichi, and I will give you the lecture regarding the radiation and remediation activities. So, let's start today's lecture. Today's theme is Kinds of Radiation and Their Characteristics, Volume 1. Are you ready?
This baseball game is very exciting, isn't it?
Correct. I always get into these baseball games.
The ball flew so far away, didn't it?
Yes, earlier I explained that there are a lot of kinds of radiation, but their characteristics, including traveling distance in the air, are totally different with each other. Today we review the kinds of radiation, and after that, I would like to talk about their representative characteristics. Earlier I explained that radiation can be categorized into two kinds of radiation: ionizing radiation, which has the ionizing effect, and non-ionizing radiation, which doesn't have the ionizing effect. Ionizing radiation consists of particle beam and electromagnetic wave, but non-ionizing radiation only consists of electromagnetic wave. Particle beam consists of charged particle beam, like alpha particle and beta particle, and non-charged particle beam, like neutron beam. Electromagnetic wave with ionizing effect includes X-ray and gamma ray, and electromagnetic wave without the ionizing effect includes, for example, electric wave, infrared and visible light. Regarding the ionizing effect, please see the relevant animation. This channel focuses on the contents, which are relevant to the countermeasures against environmental contamination, when unexpected events occur, like an accident of nuclear power plant. Therefore, here I would like to especially focus on three kinds of radiation: alpha particle, beta particle and gamma ray, which are intimately related with the unexpected events. First, alpha particle, an alpha ray. A particle, which is emitted as a result of alpha decay, and has two protons and two neutrons, that corresponds to an atom core of helium atom, are called an alpha particle. And a beam of an alpha particle is called an alpha ray. And it is a charged particle beam with positive charge, as explained earlier. And when an alpha particle is emitted, the atom number decreases by 2, and the mass number decreases by 4. For example, when radium-226, whose atom number is 88, emits an alpha ray, as a result of an alpha decay, it will become radium-222, whose atomic number is 86. Alpha ray excites fluorescent materials, therefore, once quite small amounts of radium were used as luminous paint at dial faces of watches. However, they have been already replaced with something safer. For the next, beta ray. An electron or a positron, emitted as a result of a beta decay, is called a beta particle. And a flow of this beta particle is called a beta ray, and it is a charged particle beam like an alpha ray. An electron has a negative charge, and a positron has a positive charge. If a beta ray is emitted, atomic number increases by 1, or decreases by 1. Specifically, if an electron is emitted, atomic number increases by 1, and if a positron is emitted, atomic number decreases by 1. But mass number doesn't change. Iodine can be taken as an example of emission of a beta ray. If an iodine-131, whose atomic number is 53, emits a beta ray, in the form of an electron, it will change into xenon-131, whose atomic number is 54. Taking advantage of a characteristic of iodine, which is likely to be accumulated in thyroid, for example, beta ray emitted by iodine-133, is used to treat thyroid cancer. At last, gamma ray. A gamma ray is an electromagnetic wave, emitted as a result of a gamma decay. Unlike the alpha ray or the beta ray, the gamma ray doesn't have any charge. It is an electromagnetic wave, therefore it travels space with mutual and successive interaction of electric field and magnetic field. Even if a gamma ray is emitted, neither the atomic number nor the mass number will change. Cobalt can be taken as an example of a radioactive material, which emits gamma rays. Cobalt-60, whose atomic number is 27, emits beta rays, as a result of the beta decay, and it changes into nickel-60. The nickel-60 further emits successive energy, as gamma rays, as a result of the gamma decay. Taking advantage of impact on living things, the gamma ray emitted as a result of the decay of a cobalt-60, for example, is used to extend shelf life of foods, by irradiating gamma ray, as an alternative of pesticide or medicament.
I see. Today we have learned only 3 kinds of radiation: alpha ray, beta ray, and gamma ray. However, these 3 kinds of radiations have their own characteristics, and they are used for a variety of purposes.
Correct. Let us finish today's talk now, and in the next and the following lectures, I will go into more detail, with regard to their characteristics of each radiation, as well as the difference of impact on people's health. So, let me wrap up my lecture by providing you the key points. Today I talked briefly about 3 kinds of representative radiation, and their characteristics, which are emitted as a result of decays of atom cores. First of all, an alpha particle is a charged particle beam, with the same structure of an atom core of a helium atom, emitted as a result of an alpha decay. Next, a beta particle is also a charged particle beam, and it is an electron or positron, emitted as a result of a beta decay. Lastly, a gamma ray is an electromagnetic wave, emitted as a result of a gamma decay. In addition, changes of atomic numbers and mass numbers, accompanied with the emission of radiation, are also covered. Application of each radiation are also briefly touched, although they are just examples among a large number of actual cases of their utilization. Radioactive materials which emit alpha particle were once used as luminous painted dial faces of watches. Beta particle is used for the treatment of thyroid cancer. And gamma ray is these days used for the sterilization, or for insecticidal purposes of foodstuff. Okay, today's lecture is now dismissed. See you next time. In this channel, the useful information regarding the radiation and remediation will be provided to you. If you like it, please subscribe to this channel, and do not forget to click the like button.